So let me start with some quick definition and terminologies. So we want to describe behavior of function with the appropriate terminologies and definitions. Suppose your function is increasing like this. Well, we want to make sure when your function increases. So here is quick criteria. Whenever you pick pair of values x1 and x2 where x2 is larger, then you can compare function values. The largest x2 gives you largest function value. That is a good characterization. So for any pair of x1, x2 where x2 is larger, you compare function value f of x1 and f of x2. Whenever this is larger, we say your function is increasing, like this. Conversely, whenever your function has graph like that, then you can compare two function values. Even when x2 is larger, function value is smaller than f of x1. So you will say whenever pair of input x1 and x2 gives you the reversed inequality. So f of x1 and f of x2. You compare those two, and even when x2 is larger, the function value is, f of x1 is larger than this. Then we say your function is decreasing. Oops. So we need strict inequality. Okay, for the concavity, well, you can use tangent lines. So we want to say this is concave up. So you can use tangent lines. Whenever you draw tangent lines are below this curve. So we say a curve is concave upward if it is above its tangents. Conversely, we want to say this is concave downward, and if you draw tangent lines, your tangent lines are above the curve, or the curve is below tangents. If it is below the tangent lines. And sometimes your function changes its concavity from concave upward to downward, or concave downward to upward. So for example, if your function changes concavity from upward downward, we call such a point inflection point. So inflection point is the point where a curve changes concavity from upward to downward or downward to upward. Okay, so let us use this graph to find where your function is increasing, decreasing, and concavity. So we have a function that is defined from defined on an interval from 0 to 6. So you want to tell where your function is increasing and decreasing first. For this first two, let us use open interval. Your function is increasing from 0 to 1. So f is increasing on the interval from 0 to 1. This is an open interval notation. And then from 3 to 6. And similarly, your function is decreasing from 1 to 3. 3. And that's it. Okay. For the concavity, you look at the graph carefully. Your function is concave downward up to 2. So the function is concave downward from 0 to 2, and then concave upward from 2 to 4, and then concave downward from 4 to 5, and then concave upward from 5 to 6. Inflection points here, here, here. So inflection points, the point where your curve changes concavity. From 0 to 2, and then 2 to 4, and then 4 to 5, and then 5 to 6 are at x equals 2, 4, 5. Or you can indicate the point itself. So 2, comma, this value f of 2, and then 4, comma, f of 4, then 5, comma, f of 5. Well, those are not interval notation. They are coordinate notation, x coordinate, y coordinate, and so on.